we need to see why, if for two triangles, two pairs of sides have a constant ratio and one pair of corresponding angles are equal, then the triangles are similar. We stated in some other audiovisual that this is a fact. In this audiovisual, we will demonstrate why it is a fact. In the first attempt that we are taking at showing that if two triangles have two pairs of corresponding sides which are related by a constant ratio and they have one pair of equal corresponding angles, then they are similar. We are going to show why this is so, and for this particular audiovisual we are going to demonstrate that if the facts are as we have them, then it will turn out that all three sides will have their match by a constant ratio, which is the fundamental principle on which similar triangles are based. So let us take a look at what this means. First, we have the pair of matching angles that we spoke about. Because this is a right angled triangle, then it is automatic that we will have a pair of equal right angles. Also, we are taking a look at two sets or two pairs of matching sides. Sides that are related to each other in both triangles by a constant factor, or some may say a constant ratio. So the next triangle will have sides 6 centimeters and 8 centimeters. Surely we can see already how this concept and its explanation are being developed. It is not difficult to see that there is a constant factor by which two sides of the first are related to two sides of the second. We see that 2 times 3 centimeters is equal to 6 centimeters, and also that 2 times 4 centimeters is equal to 8 centimeters. If the other pair of sides are related consequentially, then we are sure that the triangles are similar. We will use Pythagoras Theorem to find the hypotenuse. Although we'll be using trigonometry in the explanation of this audiovisual, the concepts that we are using in trigonometry will not be explained in graphic details, because if we attempt to do that while proving our point, then this audiovisual will be extremely lengthy and more emphasis will be on trigonometry rather than showing that the triangles are similar. Use Pythagoras Theorem to find the hypotenuses. Of course, if we have two sides of a right angle triangle, we are taking a look at this right angle triangle, and we need to find the other, especially if the other is the hypotenuse, then we know that the other is equal to the square root of the sums of the squares by making use of Pythagoras Theorem. Therefore, we will have 3 squared plus 4 squared. We'll simplify that arithmetic expression. Square 3, we get 9. 4 squared is 16. 9 plus 16 is 25. And the square root of 25 is 5. We will go to the next right angle triangle and find the hypotenuse by the same concept. 6 squared plus 8 squared. We are using Pythagoras Theorem in finding the hypotenuse. We therefore have the square root of 6 squared, which is 36, plus 8 squared, which is 64. That will give 100, and the square root of 100 is 10. We will have 10 centimeters. Of course, I am always emphasizing that we will have 2 square roots, a positive and a negative one. However, we are talking about the sides of a triangle, which cannot be negative, so we are just taking the positive square roots. Therefore, the 10 centimeter side will take its position where the hypotenuse is. Well, it is some distance away, and we'll see the reason for that in a few seconds. There's the reason for that. Now, notice that the side that we found, which is 5 centimeters, when we multiply that by 2, we get 10 centimeters. Notice that in every single case, 2 times 3, 6 centimeters, 2 times 4, 8 centimeters, 2 times 5, 10 centimeters. Therefore, if we have two pairs of corresponding sides of two triangles and one pair of equal corresponding angles, then we are sure that the triangles are similar. They will be similar because the other side will actually turn out to be twice the other also. Therefore, if we have two pairs of corresponding sides and one pair of corresponding angles, then the other side of the two triangles will automatically be related to the sides of the first. In the same way, the two missing sides are related by the same factor. This undoubtedly proves that the triangles are similar. If the triangles are not right angled and the angles are formed by the related sides, we will show that they are similar. What we did just now, we just showed that the two triangles, if they are right angled, then the other two sides, the hypotenuses, will be related in the same way. Now we are taking a look at a pair of triangles with two pairs of corresponding sides related in the same way, and the angle, well, it is not a right angle, but this time we are saying that the angle is formed by the two sides in question. Then we will show that the other sides are going to be related in the same way. So we have your 7 centimeters related to the 21, 3 7s 21. We have the 5 related to the 15, 3 5s 15. We are sure that the two pairs of sides are related in the same way. We are sure of that already. The two angles are equal. But are they corresponding angles? Yes, they are corresponding angles because they are formed by the two sides in question. Notice that the 40 degrees is formed by the two sides in question, and also in this triangle it is formed by the two sides in question. The angles are formed by the related sides. The sides we have shown to be related, so we are sure that the angles correspond. Use the cosine rule to find the lengths of the missing sides. On this occasion, we are going to be using the cosine rule, and we will not go in depth with this cosine rule because this is not a trigonometry problem. It's a problem which shows that if we have two pairs of corresponding sides that are related by the same ratio, and we have one pair of corresponding angles, then the two triangles are similar. That is our aim and objective. The use of the cosine rule is to assist us in finding our sides or angles that are missing. So we have x squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 cosine 40. That's quite a bit. But when we are applying the cosine rule, this version of it is applied when we have two sides of a triangle and the angle that those two sides form. And it is used to find the side that is opposite to the known angle. X squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 cosine 40. And if you take a good look at it, you'll realize that if we take just this part of it, it seems to be Pythagoras Theorem, which in some ways it is related to Pythagoras Theorem because when the angle is 90 degrees, then we will have a right angle triangle and this portion of it will be eliminated. But we will simplify that very quickly. X squared, when we simplify this, the result is 20.4. The square root of 20.4. Why do we find the square root of 20.4? X squared is equal to 20.4. Take the square root of both sides. We have x is equal to the square root of 20.4, which turns out to be 4.5 centimeters. We will go straight to the other triangle. Of course, we put the 4.5 centimeters in its rightful place. And we will go straight to the next triangle. And we are onto it. Well, the animation is there in such a quick fashion, quicker than I imagined. And of course, quicker than this narration is moving. So go to the next triangle. What do we say? Y squared is equal to 15 squared plus 21 squared minus 2 times 15 times 21 cosine of 40. When we simplify that right hand side, we get y squared is equal to 183.4. Whose square root? Because y squared is 183.4, we need to find the square root of 183.4 in order to find the value of y. Y turns out to be 13.5 centimeters. And let us put that where the value of y is. Now, notice that what we have here is 3 times 4.5 centimeters equals 13.5 centimeters. And we see that the two missing sides in the triangles turn out to be related in the same way as the other pairs of sides. And since all sides of both triangles are related by a constant factor or common factor or a constant ratio, then we are sure that the two triangles are related. This triangle, as you can see, has the 7. We have the 3 7s 21. We have the 5. We have the 3 5 15. And the sides that were not known when we found them, we also realized that we have the 4.5 and then we have also the 3 times 4.5, which is equal to 13.5 centimeters. Therefore, all sides of the first are related to all sides of the second by the same factor. Therefore, the two triangles are similar. If two triangles have two pairs of related sides and a pair of equal corresponding angles, then the third pair of sides may be shown to be related to each other in the same way as the others are related to each other. The triangles are therefore similar. This version of the cosine rule is applied when we have two known sides of a triangle and the angle that they form. It is used to find the side opposite to the known angle. And you may review this audiovisual in order to get a better grasp of the particular application of the cosine rule. Here we go again. On this occasion, the triangles are not right angled. And we can see that the sides are related by a common factor. We have the 12th side multiplied by 1.5 is equal to 18 centimeters. the 10 side, we multiply by 1.5, and that's equal to 15 centimeters. And we need a pair of equal related angles. Notice what we have. That's easy to see. 12, 1.5 is 18, 10, 1.5 is 15. We will insert equal corresponding angles. There we have equal corresponding angles. And we need to show that if we have two pairs of sides that are related to each other by a constant factor, say in this case 1.5, and we have a pair of equal corresponding angles, then the triangles are similar. Use the sine rule to find another angle. Now, those are the angles that we are attempting to find. They are currently unknown angles. So in this triangle, we have the angle Q and the side opposite to it. We also have the angle 75 degrees and the side opposite to it. Why do we have it like this? We have it like this because we are attempting to use the sine rule, and the sine rule makes use of angles and sides that are opposite to each other. As a matter of fact, the sine rule is only applicable when we have a known side and a known angle opposite to each other. Sine A over A, that's a general representation of the sine rule. Sine A over A is equal to sine B over B. That's a general representation of the sine rule. We will make substitutions in such a way that the only unknown that we have in the equation is Q, and we'll find that unknown. Therefore, opposite to Q we have 15, and of course Q will go in the place of the angle. And then we will move to the other pair where 18 centimeters is opposite to 75 degrees, and they take their rightful place on the other side of the equation. On one side we have the angle and the side opposite to it, and the other we have the angle and the side opposite to it. And of course we are taking sine of the angle, hence the sine rule. We are going to simplify or solve this equation by eliminating the 15 that we are dividing by. We are trying to find sine Q, or eventually Q. When we do that, multiply by 15 on the other side also. So we are solving this equation by multiplying by 15 on both sides. On the left hand side, to eliminate the 15 that we are dividing by, and on the right hand side we also multiply by 15 in order to balance the equation. We therefore have Q is equal to 15 times sine 75 divided by 18, and we're going to be just writing the single figure for that. Sine Q is equal to 0.8. Then we need to find Q by taking the sine inverse of 0.8. If sine of Q is 0.8, then Q is the sine inverse of 0.8, which turns out to be 54 degrees. We will go to the next triangle and we will find the angle P in the same way by taking a look at, of course, the angle and the side opposite to it in each case. So we have sine A over A is equal to sine B over B, and that is the general representation of the sine rule. We are going to make use of the known. Well, the known will be on one side and both of them will be in the same fraction. One is opposite to the other they will be on the same side. However, we are going to make the substitution of the unknowns first. Well, the single unknown. So we will have 10 is opposite to P, and 12 is opposite to 75. We will go straight ahead in solving this equation, which we will do by eliminating the 10 that we are dividing by on this left hand side. We will do that by multiplying by 10, and we will balance the equation by multiplying by 10 on the other side also. See, the 10s are eliminated, and then we'll have sine P is equal to 10 sine 75 divided by 12, which turns out to be 0.8. If two angles have the same sign, not sign in terms of negative and positive, but sign in terms of the trig ratio, the sine of this angle is 0.8, the sine of the other is 0.8, then we are sure that the two angles are equal. We could have stopped there, but we will just continue to find the angle itself, which turns out to be the same. There is no surprise since they have the same sign. Sine Q is 0.8, sine P is 0.8. Finding the two angles, do not forget that two triangles are similar if we can find two pairs of corresponding angles that are equal. And we know that if we have two pairs of corresponding angles that are equal, then the other one is going to be automatically equal. That is, the other pair of angles will automatically be equal. This proves that two pairs of corresponding angles are equal. The third pair will automatically be equal. The triangles are similar. The sine rules require that a known angle and a known side are opposite to each other. If we are applying the sine rule, we need a known side and a known angle which are opposite to each other. Therefore, we have shown in this autovisual that if we have two pairs of corresponding sides, sides that are related to each other by a constant ratio, or we may say by a common factor, we also have two angles which correspond and are equal, then the triangles will be similar. And we have done that for a right angle triangle, and we have done that to show that the sides will be related, and we have done that to show that the other angle will consequently be equal. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.